and inshallah the seminar today will be about wireless technologies. So on behalf of the Computer Engineering Student Club, I welcome you, and please welcome Dr.
Assalamu alaikum. My name is Ashraf. I'm a faculty with the computer engineering. I teach courses mostly in the undergraduate level. I teach data and computer communication. I actually just came out of the class 15 minutes. So my students, some of them are here. They will see that this is useful also to their course because they have to write an essay about some of these topics. I also teach for the graduate level courses that, especially in the wireless and mobile computing. And I also teach the computer networks and some of the other simulation and computer performance courses. Today, the talk is about wireless networks and technology. I have said that I will talk about wide area wireless networks and talk a little bit about wireless LAN, which is wireless local area networks. And then talk about the situation in Saudi Arabia in terms of business opportunities and providers and services. But then when I looked at the amount of material, it was too huge. So I limited it to wide area wireless networks, which is the ones that we are using. And I will leave the other part, which has to do with Wi-Fi, wireless sensor networks, pervasive computing, ubiquitous computing, home networking. All these things can be summed in one other talk, maybe some other professor or me again later on, some few weeks later. I will do it. So for today, I will just introduce the concept. How did it look like 20 years ago? And then talk about very basic concepts. Something like the mobile channel. Why it's difficult? Why is the wireless communication stands different from other types of communication? And then I will talk a little bit about multiple access techniques. Just survey them in 1 or 2 slides. And then we'll go into 4, 5, 6, and these 4 and 5 will be the main talk. Talk about the future, the evolution, how these things are evolving in time. Okay? And in number 5, I will reflect that into the situation in the kingdom here. And I will tell you about the efforts that are being taken by companies, by the government in these fields. Okay? So, as far as the evolution is concerned, about 30 to 20, 40 years ago, people started to realize that to do wireless communication is very, very interesting, very, very low cost, almost, because you don't need to set up an infrastructure. So they started talking about voice systems, and at the same time there were some data systems. We always have the feeling that voice was earlier than data, but in reality data was earlier. In the 70s there were wireless LANs. In the 70s. They were not as good and as fast as the wireless LANs that we have here, but they existed. So the history of these systems go back all the way to the 70s. At that time, they used to make a system which is either voice or data. For voice, we have systems like where extension to the public switch telephony. So we have the telephone we enjoy at every house. Now we want to take this telephone with us everywhere. So the wireless system was born. And Bell Labs did their first deployment in the 70s for these cellular phones that provide you with voice. At the same time, there were wireless LANs also being deployed in warehouses, in factories, in places where you need to communicate using data. But it was giving what? We're talking about 9 kilobits per second. These were the rates at that time. And there were lots of limitations only. Not only the rates, but the infrastructure is not there. The internet was not mature at that time. Okay? Now the situation is different. So this is the history for these things. So at that time, there were either data or voice. This is a history line for some of the voice systems. It goes all the way back to the 70s, and this was in Bell Labs when they came up with their cellular technology deployed in New York. The phones at that time, they were this bulky. They were very big. And now if you compare them to the phones that we have now, and the capability of the phones now are completely different. Now, so systems have different capabilities. This chart is very famous in the wireless literature. If you look at the x-axis, this is how many megabits per second you can do. And on the y-axis, this is the mobility. On the y-axis, the lowest part, and you're talking about static user. He doesn't move. So you can actually give him more bits per second. It's easy. But as he starts to move faster and faster, giving him more bits per second becomes very hard. That's why usually with systems, even with you, in your car, when you make voice call, there's a very good chance if you go very fast, the voice call will be dropped. Because the system cannot keep the link at extreme speeds. All these systems, they have limitations. So you can see here, initially we have the 2G systems. They have moderate rates, but they can support all mobility, all kinds of mobility. And then in around 2000, they wanted to increase the rates with still good support for mobility. And we have these systems towards the end here. They are providing extreme rates, like this system here. We are providing something like 100 megabits per second, but only for fixed users. We cannot provide these 100 megabits per second for users that are extremely fast here, so we don't have something here. But this was only 5 or 10 years ago. Now the picture is a bit different, as I will show you. Okay? We call this envelope the technology envelope. We always want to push this envelope towards this side, meaning getting more bits per second and also supporting higher speeds. Right now, there are trains in Japan or in France that go at excess of 700 or 800 kilometers per hour. And these trains have to be internet connected. With these systems, you can. It's very difficult. We need newer technologies. Okay? And I will show you what kind of technologies is able to provide that. So let's talk why the wireless channel is different. Why everybody is saying, okay, wireless engineers should be different than other type of communication engineers. Because the wireless channel is very different. The wireless channels have these problems, all these problems. The power goes dramatically low with the distance. You start with 1 watt here, you send it, and immediately after, say, 1 meter, it's almost gone. Okay? So this is not the case when you send on a wire. When you send on a wire, the power doesn't drop dramatically. The biggest problem also, one of the bigger problems there is obstacles. Obstacles that exist between the transmitter and the receiver or the base station and the user, they completely change the wireless environment, the propagation. And they make it extremely difficult. You send something and you get something else. You get many reflections. Everybody is familiar with reflections or getting double sounds on their radio. That's because of reflections. And this happens with wireless communication. I'll give multipath towards the end. There is this Doppler speed, Doppler spread. When you have a car moving and you are talking on the phone, the frequency, which is fixed, say 900 megahertz, is not 900 megahertz anymore. It's 900 megahertz plus minus because of your speed. It's exactly like you standing in front of a train which is coming. You listen to the voice of the train. It sounds different when it's coming towards you and when it's going away from you. The frequency of the sound is different. The same thing with the signal in your phone. When you are speeding away from the base station, the frequency is different than when you are speeding in towards the base station. So all these things make the wireless environment very tough to handle. This is the case with multipath. Multipath is the main phenomena that makes the wireless channel very difficult.